Let's dive right into what is arguably one of the biggest hidden traps in data science. And to do that, I'm going to kick things off by making you a really bold, honestly borderline arrogant promise. I can build you a cancer detection model that is 95% accurate today in one line. Here it is. It says no cancer to every single patient. Boom. Done. Now, the crazy thing here is, technically, this model is completely finished. And yes, it is absolutely 95% accurate. But it's also completely and dangerously useless. Understanding exactly why that happens is hands down the most important lesson you can learn about measuring machine learning models. Okay, so let's look at the setup. 95 healthy, 5 sick. Let's actually visualize how this trick works. Imagine we've got a screening test for a disease that affects, say, 5 out of every 100 people. So in our little group here, 95 people are perfectly healthy and 5 are actually sick. Now suppose we build the absolute laziest model imaginable. I mean, a model that literally ignores every single scan, ignores every symptom, and just blindly declares every single patient to be healthy, no matter what. So how often is it right? Well, think about it. It's right on all 95 healthy people, right? It's only wrong on the 5 sick ones. That's 95 out of 100 correct. On paper, that gives you a massive, incredibly fantastic-looking 95% accuracy score. But here's the really shocking reality. That same model failed completely, exactly 100% of the time, on the only job that actually mattered. It literally missed every single person who actually had the disease. The whole metric of accuracy basically just cheerfully hid an absolute total disaster right behind a big reassuring number. Which brings us to the accuracy paradox. Yeah, this villain actually has a formal name, the accuracy paradox. It strikes basically whenever your classes are imbalanced, and that just simply means one outcome is way rarer than the other. When that happens, you get this artificially high accuracy, simply by predicting the most common outcome every single time. And just think about how ridiculously common this is in the real world. Fraudulent transactions, those are super rare compared to normal bank transactions. Serious diseases are rare among all the patients coming into a clinic. Defective parts are rare on a good assembly line. In literally every single one of these scenarios, finding that rare event is the whole entire point. And yet, accuracy is precisely the metric that lets you completely ignore it while still patting yourself on the back. So, what is the golden rule of accuracy? How do data professionals actually protect themselves from falling into this trap? Well, good data scientists treat raw accuracy on imbalanced problems with deep, deep suspicion. That is exactly why their very first question is never, hey, what's the accuracy score? Instead, they ask, what's the balance of the classes? So, here is your main takeaway from all this. It's a rule that's going to protect you every single time someone waves an impressive number in your face. Never trust accuracy alone. Always, always ask what it's hiding. Because on the problems that really matter most, the rare, the costly, the literal life and death problems, a single accuracy number just isn't an answer. It's oftentimes just a trick. So, I'm going to leave you with this to chew on. The very next time a software vendor or maybe a researcher waves some ridiculously high accuracy number at you, are they actually showing you the truth? Or is it really just a magician's misdirection?